All right, so like I said, 7-1, ratio and proportion. What vocab to begin with. Definition for ratio that I want you to be responsible for knowing is that it is a comparison of two numerical quantities measured in the same units. And one important part with that that's sometimes forgotten, to be a ratio, they're numbers, numerical quantities, and they have to be in the same units. So I'd underline or star, put some kind of mark next to that, because that's the thing that sometimes gets forgotten. By units, what kind of things are we talking about? Feet would be one. What's another one? Inches. What else? Centimeters. That's all for length. What are some other units that aren't for length? That aren't for length. What? Grams or mass. What about for volume? Meters, that kind of stuff. I said meters. Sorry, I misheard. So that kind of stuff. If you're going to write that ratio, then you need to convert the units so that they're the same. So if one's in feet, one's in inches, do the conversion to get them to be the same. Doesn't really matter which way you go, you pick, because the ratio will end up being the same no matter which way you went with it. But you got to get them to be the same. Examples of how these can be written. You can actually just use the word 2, and that's usually how we'll read this. 8 centimeters to 12 centimeters. Two numerical quantities in the same unit. I'll just put the word 2 between. We could also just use a colon. So we could say 8 centimeters. We can still read it as 2 12 centimeters. That's a really common way to write it. I won't really very often actually write the word 2. I'll usually use the colon. And then the final way that we'll work with a lot as well is just writing it as a fraction. In ratios, that's really often how we think about them as things that are fractions. Another place you hear that before, we talked last year in Algebra 1 about rational numbers. Rational, things that could be written as ratios, things that could be written as fractions. So you like that? When we're working with these, we're going to want to simplify them, but that's going to work just like how you simplify any other fraction. So since ratios are fractions, they should always be written in simplest form. Since ratios are fractions, they should always be written in simplest form. So the one that we just looked at, the 8 to 12, is that in simplest form? There's some stuff that we can do, so let's go ahead and work on that. Just like any other fraction, when you look at it, you think about what's a common factor of both of them. So I can take 4 out. Now you won't always write this, but what you're really doing is 4 times what? Up top.
8.
Well, 4 times what gives you 8? 2. Over 4 times 3. What happens with 4 over 4? Cancel out. So 2/3 is what you're left with. The deal is, like with regular numbers, I wouldn't really expect you to have to do that. But sometimes maybe those are going to have variables and things like that, where you might just have to think about it like canceling out. Like if I gave you, maybe it was 8x squared over 12x to the third.
You want us to write about?
If you had something like that, it's going to be one of two things. You can either just think about it, or you can write it out. If it's x squared, how many x's are there? So it'd be 8 times x times x. How many on the bottom? So how many cancel out? That's gone, that's gone, that's gone. So I'm left with 1 on the bottom still. You might just be able to think about it, though, but that's what's really going on.
So
How do you finish it? Well, the 8 over 12 would still become 2 over 3, so I'd leave it as 2 over 3x. Because there's 1 x left, and it was on the bottom, so it stays there.
So you don't solve for the division.
With this case, if it's a regular ratio, see how there was no equal sign to begin with?
Yeah.
It's not an equation, so we can simplify it, but we can't solve. By the end of this lesson, though, we are going to have one with equal signs, and then we will be solving for the variable. But If it's just this, there's nothing to do like them. So simplification, we just did. And then again, you can rewrite it as either 2 to 3, 2 to 3, or 2 over 3. So next one, example 1, we're going to simplify part A here. 12x to 16x. 12x to 16x. One of my recommendations would be when you're given these ratios, if it's not written as a fraction to begin with, if you have to actually do some work with it, probably rewrite it so it is a fraction. So I could say that this is the same thing as 12x over 16x. What's going to happen with the x's? Yeah, I had one on top, one on bottom, so they're actually both just gone now. 12 over 16, what goes in both of them? What do I have left on top then? 4. So that's a simplified version of that ratio. The x's canceled out, took a 4 out of numerator and denominator, left with 3 over 4. And with these, again, I know a couple of you already asked, and I don't necessarily expect to see a whole lot of work. If you can look at that and just immediately see, oh, 3 over 4, that's fine. I'd be pretty understanding of not seeing a whole lot of work on that one. It's kind of simple. One more. 6 feet over 18 inches. 6 feet over 18 inches. What's a little bit different about this one? So what do we have to do first? Which one do you want to convert to which one? Inches to feet? Okay, what do I do to go from 18 inches in feet? So do that. It's going to be 6 foot over. If I take 18 divided by 12, what am I going to get? 1.5. So now that the units are the same, I can actually divide. What's 6 divided by 1.5? And I'm going to actually write that as 4 over 1. Reasoning would be, with a ratio, we want it to be in a fractional form because it needs to be a comparison. So even though normally you just write your answer as 4, if the answer is supposed to be a ratio, keep it as a fraction. So if you get a whole number, always put it. Would this work and give me the same answer if I converted feet into inches? Let's try and just make sure. If I want to go from feet to inches, what do I do? And 6 times 12? Yeah, so 72 inches over 18 inches. What's 72 divided by 18? I get the same thing. And that's always going to be true. It does not matter which way you go with the units. You can convert either one into either one and then do it. You'll still get the same result. Now, a lot of times for me, like I think it's easier to multiply. So I'll usually turn the bigger unit into the smaller one, but it really doesn't matter. Whichever one you want to do, it works. Questions about those? Next example, the ratio of two numbers is 4 to 5. So I'm giving you the comparison. If the sum of the two numbers is 36, what are the two numbers? So you're writing, you're thinking about how we might be able to figure this out. Again, I'm giving you the ratio, giving you the sum. We want to come up with what are the actual two numbers. So it is kind of like we're going to go backwards. The ratio is 4 over 5 simplified. Yes or no? Yeah. So we've got to figure out what two numbers simplify into 4 over 5, but add up to 36. So one thing we can do, maybe just a little guessing and checking. First pair would be 4 and 5. Do those add up to 36? what other two numbers would have a ratio of 4 to 5? And what do you do to get that? Okay. Do those add up to 36? Next step would be if I triple this,
12 to 15.
do those add up to 36? Okay, what if I quadruple it?
16 to 20.
Do those work? So that's our answer. Do you think that's going to be a very good method to use very often, though? Yeah, exactly. And in this case, 36 is a pretty small sum, so that wasn't too bad. But what if I wanted to know the sum when it's 17,432
Oh, wow.
or some big number? You don't want to guess and check all the way through because even though it would eventually work, it would take forever. And you don't do that. So there's a better way. The idea is, what did we do to this ratio each time to get one of these things? We multiply by one more. So we multiply them both by the same thing. What if we just figure out what we have to multiply by? Then we can do it. And you can do that by setting up a portion, which would look like this. 4x over 5x equals 4 over 5. Now, the reason why that's equivalent, we've already looked at this a little bit before. What's going to happen with those x's? So I still get the same ratio. I just added the x in. But what do I know that 4x and 5x are supposed to add up to for this problem? So I could do 4x plus 5x equals 36. Can we solve that? First step. So I get 9x equals 36. Then what do I get? Is 4 one of my numbers? What is 4? What is that telling me?
You take
It's our multiplier. It's what we multiply by. So to finish it, 4 times 4, 16. 4 times 5, 20. So we get what we were supposed to get. But it's a much more efficient way of getting the answer because it didn't matter how big this sum was. I just had to divide it by 9, and I was going to get that multiplier, and then I do it. So that's how I work those out. Guessing and checking can work. Not very effective, though. It'll take a lot of time. Another one kind of like that. The ratio between 3 angles of a triangle is 3 to 4, 5. What is the change? Now this one's technically called like a combined ratio because you've got more than 2 things being compared. I'm comparing all 3 angles, but it really works the exact same way. You just really wouldn't be able to write it as a fraction. So any thoughts on how to set this one up? Think about what we did on the last one. Exactly. So it's going to equal 180. What's going to be on the left side? Very good, Raylan. So in this problem, did I tell you what the sum was? But we know it because it's a triangle. Doesn't matter what kind it is because that sum of the angles is always 180. Solve it just like we did the last one. 3 plus 4 plus 5. So 12x equals 180. Then and 180 divided by 12.
15.
So what is 15? What is that number? Remember, we got to multiply them all by. So now I do that. 3 times 45, or sorry, 3 times 15, 45, thinking ahead. 4 times 15. And then final one, 5 times 15. What's a really easy way to check our answer now?
I don't know.
So what do I get when I add 45, 60, and 75? So I'm really sure we did that right. That's how we do that. If they would give you perimeter, you do a pretty similar thing, because what is perimeter? Yeah, rounded is what you get when you add them all up. So if they told you that, you'd say that. And that's how those work. poster is 1 meter long and 52 centimeters wide. Find the ratio of width to length. So we're just going to write down and then eventually reduce this. Find the ratio of width to length. What number should go up top? Why 52? Yeah, read what it says. Width to length. Width comes first, therefore it's on top. It doesn't matter which one comes first here, which one's bigger or smaller. It matters what they tell you to do. So 52 centimeters on top, 1 meter on the bottom. Well, what's my problem right now? Which one do you want to change? Okay. 1 meter is how many centimeters? So 52 centimeters over 100 centimeters. Can I reduce that? Yep. 13 over 25 would be the simplest it gets. Now, if you saw 2 to begin with, you get 26 over 50, but then you can always reduce it again. So, always get it in simplest terms. It does matter how they tell you to do it. If you gave me 25 over 13, it'd almost be right, but not really. Because it asks for width to length, it needs to be width to length. This mainly kind of relates to what you said earlier about like solving. This is when we're going to do that. A proportion is a statement that 2 ratios are equal to each other. A proportion is a statement that 2 ratios are equal to each other. We did these in Algebra 1 last year. I don't know, when I was working with the lab students yesterday, they knew how to do it pretty well. The examples, just look at these. You're not going to necessarily write these down, but just here's what these can look like. You don't have to write. Could just be 2 numbers. So we've already actually done this. 3/5 is equivalent to 27 over 45. This 27 over 45 reduces to 3 over 5. So that's a proportion. Could be ones with variables all over the place. And it could be ones that have a combination of variables and numbers. This one we wouldn't be able to solve, but we'll actually remember how to solve the ones like on the bottom. To do that, a little bit of vocab to know. Some properties of proportions. If you have sum A over B equal to some other ratio, C over D, C and B, those are called the means. It's in the top right and bottom left. The extremes, top left, bottom right. So just get those labeled somehow. Means, top right, bottom left, extremes, top left, bottom right. And we're going to use those to actually solve these. May remember what you did in Algebra 1 to solve a proportion. We're going to cross multiply. It's not going to be any different than what you've already done. Same idea. For that, we're going to skip. This is the cross multiplying, or the setup there, cross product. Same idea, because product means you are. Yeah. And what that says is the product of the means is equal to the product of the extremes. And that's what it meant to cross multiply. You multiply the means, set that equal to the multiplication of the extremes. That's always in that cross. It doesn't matter if you have variables, if you have whole numbers, you still can multiply them. sometimes what you might notice, if when you do that cross multiplication, you get the same thing on the left as you do on the right. That just meant those two proportions, or those two parts of the proportion were equal. Back to the lettering. If A over B equals C over D, then AD equals BC. A times D, that's 1 cross, and then B times C, that's it. And you just have and then from there, you'll be able to just do whatever algebra you need to resolve. It'll usually just involve one division step. And that's it. One other little trick that we'll be able to use sometimes, and kind of specialize when you might want it or not. But if you know that two ratios are equal, then their reciprocals are also equal. If you know that two ratios are equal, then the reciprocals are also equal. What do you do when you write a reciprocal? You flip it over. So what this says is if you have a proportion, you can always flip them both over. And there are cases where that's just going to make the work easier. It's probably not going to be something that you have to do, but it's an option. You can always flip them over, but if you flip one over, well, you have to do the other one. Just like most rules of algebra, whatever you do to one side, you got to do the other. So you can't just pick and choose. So using our letters, that would be like if A over B equals C over D, then B over A equals D over C. Flip them both over, that's always an option. So examples of solving these now. We're going to solve each of the following proportions. And what it means by solve is just like what it means by solving any equation. You're supposed to do what? What does it mean to solve an equation? Find the variable, and that's a way to check it too. You're going to find whatever variable, so in this case x, and then you have to plug it back in, we'll be able to check it, and we'll actually do that on the first one. So I've got x plus 1 over x plus 3 equals 4 over 5. It's a proportion, so what's my first step? Cross multiply. So it's going to be x plus 1 times 5, and then 4 times x plus 3. It's not just 5 times x, though. It's 5 times, so we've got to write it with some parentheses. 5 times x plus 1 is going to equal, what's the other product? Why did I write the parentheses like that? Because I have to distribute. And it's because of what I just said. It's not just 5 times x, it's 5 times that whole thing. So distribute the 5, distribute the 4. What do I get? Don't forget to do that. Distribute if you need to. Solve it like any other algebra problem. What's next? So which one? Yeah, it doesn't really matter. 4x might be easier because then I don't have the negative. 5x minus 4x gives me x. Yep. X does equal 7. And I'm gonna do what Ella said, and I'm gonna plug it back in just to make sure I'm right. So it's gonna be 7 plus 1 over 7 plus 3 gives me 8/10, which reduces down to, so it is right. It gives me an equivalent ratio. All right then. Why don't you go ahead and try this next one on your own? Really not too different from what we just did. Cross multiply, see what you get. That's what y'all came up with. In this case, we had a fractional answer. Fraction doesn't reduce, so like that. I prefer the fraction of the decimal because that's exact, and your decimal's probably going to be repeating. What you doing? Any questions about the work that's up there? Yeah. One last one. What do you know about this one that makes it a little bit more complicated? Yeah, I got them all over the place. Every single numerator and denominator has a variable. So we're going to remember some old stuff from Algebra 1 that you might not have done for a little bit. Still going to cross multiply, so it's going to be x times, and then x minus 4 times x plus 5. So write that down first. X times x equals x plus 5 times x minus 4. Yeah, like Sarah already said, x times x is the same thing as x squared because you have two of them. Now, remember how you multiply out something like this? Will. What's the acronym?
No, every little answer. Isn't it first, outside, inside, and last?
Exactly. So first, you look at each binomial. What's first in each one? And x times x, we've already said, is x squared. Outside is x times negative 4.
So minus 4x.
Yeah. Inside is 5 and x.
Don't they always cancel out?
If they're, like if this was a minus 4 and that was a plus 4, yes. But if the numbers aren't the same, then last would be 5 times negative 4. Now we keep going. On the right side, what's negative 4x plus 5x? Okay, so I get x squared equals x squared plus x minus 20.
Can you just turn off the X?
Since we're adding, I actually can't put them together at all because they're not like terms. Yeah, if you're multiplying, yes, it would be x cubed. But if we're adding, I just have to leave it like it is. But now, if I want to get rid of this x squared, since it's positive, how do I move it to this side? And what do you know is going to happen? It's gone. How can I get rid of that minus 20? Add 20. So x does equal 4. Now that's a little bit more challenging than what I probably expect you to be able to do at this point. But stuff like that, we're going to be reviewing a little bit more this semester since it's going to be a crowd for next year. So that is that. So your assignment is right there. So go and write that down. We'll work a few of these out together. And then be moving on to the next section. Yeah, that's what I said.